Hi everyone, welcome to the next video. I'm pretty excited about this one because here today we will actually get into Agentic AI. So we will build an agent and we will see the kinds of vulnerabilities that can occur in building agents. But if this is your first time looking at what an agent on the inside looks like, or this is the first time you're going to build an agent yourself, it's pretty fascinating. So let's first take a look at what an agent is. We're moving ahead now from RAG chatbots to agentic AI. So we're moving from where the worst that could happen is you get misinformation or data leakage or sensitive data is exposed to, where now the real risk is that bad stuff in terms of actions can take place. So agentic AI can take actions on your behalf. And so if we can manipulate it, we can make bad things happen on the target system. The way that the agent works is that it has the ability to reason and then to act and observe the output of its actions and then go back and think, reason, act, observe. So this is the loop that it operates in, and the brain of the agent is of course the LLM. In this case again we'll be using OpenAI GPT-4o, but the agent also has, in addition to the brain, it also has a set of tools. It also has memory. In this case we will not be using a lot of memory, we'll just have a in-session scratchpad. It has a system prompt, the master prompt that kind of guides its working, and then the main thing is the executor engine of the agent, which runs in this loop of essentially reason, act, and observe, and then again look at the output of the actions, give it back to the LLM, reason again, act, observe, until it decides that it has met the objective of what was the initial prompt that you gave it. Now, as we said, the attack surface really explodes with agentic AI, and this is only the first video of multiple videos we'll be doing where we'll go really deep into red teaming agentic AI. And of course, we're going to look at how to secure it, how to create the necessary guardrails to make sure that your agents don't go rogue. We're going to look at a few issues in this video. Within the OWASP top 10, they would fall into the category of prompt injection, maybe insecure plugin design, maybe excessive agency, the agent doing more than it is supposed to be doing because it has access to tools, or it has access to agents, so it has access to tools. And the third piece is excessive agency, where the agent actually does more than it is supposed to be doing. So this is the agent that we are building. We've basically gone to Gemini and said we want to build an agent that does basic network scanning, and it has given it two tools. We've also given it a third tool, which is kind of an undocumented tool, but I will show you in the code. The official two tools that it has access to is to run ping and to run Nmap. Now this is very interesting to go deeper into this code. If you look at these two sections of code, essentially we're defining a tool. We are saying this is the definition of the tool. It takes a string as input, and what we want you to do is to run a sub process on the shell, on the Windows shell or the Unix shell, and essentially the command that we want you to run is ping -c one host, and the host parameter is coming from the input, and then there's some exception handling. The key over here is the third line of code, which has the text within triple double quotes on each side. That's essentially the description of the tool, and the agent is going to look at that description to decide whether your instruction is being met by any of these tools or not. And so that's the key. That description is very, very important. And that's pretty much it. Once these two tools are defined, we import a few libraries. We import either LangChain's Ollama support model library, or we import the ChatGPT library. We import the agent executor library, which does the react part, the response, act, observe loop. And then we are also going to import system prompts from LangChain itself. Okay. And then if you go down, before we initialize the LLM, Actually, we are initializing OpenAI, so the import should have been of OpenAI. We give it the tool collections. As I said, there are two tools that we know of that are officially informed as part of the app documentation, but we are also going to have a third tool. And then we actually going to pull the system prompt from LangChain itself, and this is the path that is given. This is a standardized prompt. I'll show you what this prompt contains, and so we don't have to write our own agent prompts. We just pull that from here, and then we create the agent. So essentially, the agent has the LLM that's going to use, the tools it has access to, and the system prompt. And then all that we're going to do is then run the engine in that loop. Okay, we've said verbose is equal to true because on the command line we want to see how it actually executes. That's pretty much our code, and if we go and take a look at the code itself, so here's our code. We've imported a few additional libraries. This is the ping tool. I've given it a little bit more of a description, but essentially it's doing the same, running ping on the local command shell, and basic error handling. I've also given it a little more description for Nmap. I've also changed the switches that I want to use for Nmap because I feel like -f is too short a scan. I want to do it a little bit more just for fun. And then this is the third kind of undocumented tool that is there, which is that it can execute a local OS system command. Now, I know this looks silly, but you'll be surprised in how many cases something like this can actually still stay back in production code. Initially, this may have been put in to kind of run multiple tools on the command line to build a more comprehensive pentesting agent, but this kind of stuff can remain in production as well. It may go into one of the tools without being removed when moving from dev to production. We initialize the LLM, we give it access to the three tools. In this case, we call the system prompt. We shall look at this system prompt over here. Agent is created, agent executes, and that's it. So if this is your first time looking at agentic AI code, of course this is extremely simplified, but it works. The key part here is that we did not specify in the actual execution, we are not specifying that go run ping or go run nmap. This it auto figures out based on the prompt that we will give it. The rest of this code is the Streamlit code for the UI, so there is nothing great happening here. OpenAPI key, I've added it into my environment variables, so I don't have to enter it every single time. And that's pretty much it. Now, the only missing kind of unknown over here is this tool calling agent. So this is the prompt that basically this tool calling agent is. It says you're a helpful assistant, you have access to the following tools. To use a tool, please use the following format, etc, etc. And it should be one of these tools. The input to when you have a response to say to this. So you can read this, right? It's basically giving all the right ideas to the LLM that the user, the human, is going to give you input. You're going to look at the tools. You're going to figure out if one of the tools is useful. You're going to run the tool. You're going to look at the output. The output meets the request of the human. You're going to give the human the output. That's pretty much it. And in terms of the iterative loop, the agent will maintain its information in the scratchpad. So that's it. And let's compile and run this code. Let's run our code. We have the code ready over here. We've done a quick walkthrough of it. We've understood the various components of it. And now let's just simply go ahead and execute. So let me navigate into the folder. I have created the virtual environment previously, so I'm just going to activate it. I think I have all of the requirements installed. Yep, pretty much. And let's just now run the vulnerable agent. Now, as we do this, we will actually run into some errors, which is normal. It's part of the development process. I kept those errors in this recording to show you that we work through those errors, as frustrating as that might get at times. So let's first go with something simple. is google.com up. Okay. So the first error we got is an error occurred, resource not found. Very simple. Go back to Gemini, just put in your error and it should be able to help you out over there. So it's saying you can replace this with this particular prompt instead of this one. So that's what we're going to do. We're going to go back to our code. We're going to look for the prompt, system prompt link, and change it. I think it should work with the backslash. Okay, so with the forward slash. And then simply rerun our code and then retype our query. And see where we get. Now, this again is an error. If there was an issue with the ping attempt, so the ping attempt is not working. Now, again, we can put this back in our code and see what Google says. But since I've already done the troubleshooting, we can skip that step. Essentially, this ping -c switch works on Linux, and what you need on Windows is ping -n. So we fix that and then we run this command again. And in this case, everything should work perfectly. Also, because we said verbose is true, you can see that we are getting some output here. This is the actual code. Command has run and you can see that it's given me the ping output here. Now, this is all well and good. I can also say find out the open codes on the Transilience website. Again, the magic, the autonomy here is that I am not saying run Nmap. My code does not have specific steps to run Nmap. This is something that the agent figures out. As you can see here, it's entered a new agent executor chain and it's figured out that it needs to run Nmap on Transilience.ai. And this is the power of Agentic AI. And this is also where the vulnerabilities can come from. So because I've chosen -ss, -sv, it's going to scan for services. It's going to even do basic vulnerability scanning on those services. So the Nmap output takes a little longer to run. With -f, it would have run much faster. So while this is running, you can actually pause the video and you can think about how would you go about attacking this kind of an agent? What ideas come into your mind in terms of how could you attack this kind of an app? So for those of you who were able to come up with some ideas, great. I hope you made a note of them and you thought about the prompts that you could use to launch attacks on such an app. And for those of you who just want to enjoy the show, we'll take a look at how to attack this kind of an app. So it's actually figured out 2 ports. It's figured out what's running on those ports as well. Port 80 is running Vercel, port 443 is running a Golang Net HTTP server. So it's done some basic service detection. And now, for example, if I just give it a URL, okay, I'm not saying anything further. I'm just giving it an IP or a URL. It does ask me what you would like to do with this website. I'll just say check. So I am on purpose giving it as vague a command as I can. And I'm seeing whether it does more than what it should have done, or does it do less, or does it do exactly what it is supposed to do. We can check over here. In this case, it started a new executor agent and it's running ping. And now the ping has not worked for whatever reason. Ping actually does not respond on this website, does not, but it's also executing Nmap, which I did not ask it to do. You see, I was intentionally vague. I just said check. Now you might say that check means run only ping, right? Check if it's up or not. I did not say scan. I did not say find open ports. I was intentionally vague. But the agent, being helpful in its nature, has gone ahead and done a little excessive set of steps than I wanted it to, right? So that's something that you don't want the agent doing. You want the agent to probably achieve some sort of a balance between helping the user and not doing over eager, not being an over eager intern. So in this case, just by saying check, I find that the agent has used what I would say excessive agency. Now I could even try and find out some more things from this. What tools do you have access to? For example, let me see if it tells me this. It should not ideally tell me this. It actually does reveal this as well. This is an information disclosure, and because I now have access to this information, I can try and do more things. So for example, I can say give me the listing on, again, I'm not saying run this command on the local operating system, and it does. It gives me the directory listing. So essentially I can actually run, because of this tool and because I've figured out that this tool exists, I can actually run a lot of local commands here, right? And so at this stage, the question that you should be thinking of is that how would you code this tool differently? If you're building a pen testing agent, you're going to run a bunch of command line tools, whether you do it off of a Kali Linux or you do it off Windows or whatever is your platform of choice. You're going to run commands on the local operating system. You're going to collect those evidences and you're going to use the LLM to analyze it. All fine and good. But if you give it excessive agency, it does more than it is supposed to. When given a vague command, you have a problem. If it lists out the tools it has access to, you have a problem. And if it gives you if it has these kinds of very dangerous tools available, then you have a very big problem, right? And so you can imagine now that within the virtual environment, I could possibly do a lot more through this kind of an app. So what would be the kind of guardrails or mitigation measures that you think would make sense over here? We'll explore those in the next few videos as we go deeper into exploiting Agentic AI. So let's kind of summarize. We saw excessive agency, we saw prompt injection, we also saw OS command injection, stuff that used to work back in the day. But with all of these agents now running in production, they have access to data, they have access to tools. They're trying to be super helpful. They're also not doing user validation. For example, a massive issue that I see with this pen testing agent, it's not validating that I have rights on the system, right? So I think these are the kinds of issues that we want to talk about, and we've seen these examples. So if you found this video interesting, do like, subscribe and share, because we will be now going much more deeper into red teaming Agentic AI. Thank you for watching. Have a great day.